All right, let's go over our third subunit of electron configurations. This one's going to be super simple, in my opinion. Noble gas abbreviations, once you know electron configuration, this is actually easier than that. But our goals for today, I want you to be able to write electron configuration for elements and monatomic ions. So a monatomic ion, that just means one atom ion. Later in the year, we're going to learn about polyatomic ions. So that's the difference. A monatomic ion would just be like this one. N with a -3 charge. So that's it. That's the only difference. Monatomic just meaning one atom. Later we're going to have like a polyatomic ion like OH minus. So that's oxygen and hydrogen with a -1 charge. Okay. I want you to be able to write noble gas abbreviations, classify elements based on their outermost electron configuration, which we kind of did last lesson, and I want us to be able to talk about valence electrons from an electron configuration. So we know these all have one, if you watched my ions video like I asked you to a long time ago, we all know that these have one valence electron, two valence electrons, 3, 4, 5, 6, 7, 8, and I told you the d orbitals are, the d block is weird and the f block is weird. Well, now we're going to be able to determine the valence electrons. And we'll talk about what a valence electron is here in just a few seconds. So writing electron configuration from a periodic table, we're not going to do this. We kind of already did this, okay? So I want you to do this on your own. We talked about this last lesson. I would like you to have this as your reference, okay? So if you'll look at the PowerPoint, the d orbital starts with 3, okay? So keep that in mind. And then the f block, which is kind of here, that's going to start with 4. So just keep all of that in mind. Write this, do your own periodic table. If you need a new one, I have extra copies. It's in the front of the classroom in the periodic table box at the very bottom. So if you want one of those, grab it. You can print it out on your own. You can find a blank periodic table, print it out, whatever you want. So anyways, we're going to move on. So electron configuration, here's some examples. We went over how to write it in the last lesson. It was a long lesson, so we're not going to go over this again. But noble gas abbreviation. So here's the new stuff, okay? Noble gases are all located in group 18. We know this, okay? We've known this since before you even saw me. You knew these were noble gases, and this is group 18. That's what they include. So basically, how to write a noble gas abbreviation. Let's say we're doing phosphorus, electron configuration of phosphorus. So they're actually, I'm sure one of you have asked me in class by now, if you haven't already watched this video, but yes, there is a shorter way of starting from 1s2, 2s2, 2p6, 3s2, 3p3, okay? There is an easier way than writing all of that. You can actually go up and to the right, that nearest noble gas, not nearest as in this way, okay? The nearest most previous, okay? So the most previous noble gas for phosphorus's case is neon. So you would write it, for example, phosphorus, okay? That's a P, okay? So you would write it, the noble gas in brackets, okay? So that noble gas, remember, was neon, okay? So neon. Instead of writing 1s2, 2s2, 2p6, you wrote neon, okay? So instead of writing 1s2, 2s2, 2p6, okay, all of that was replaced by this bracket. That's it, okay? And so you have neon, and then you just take it from neon. So neon, you still do have to do the 3s2. Okay, so neon 3s2. And then neon 3s2, and then 3p3. Okay, so that's it. And we have a few examples up here, and we'll just move on. Electron configurations for ions. Actually, I want to do one more electron configuration shortcut. Just for fun, let's do selenium, since that includes the D block, okay? So selenium, let's write it. Go ahead and write it. Okay, so selenium, which is Se, and is right here in the P block in the 2, 3, 4, selenium P block 4. You go up to the most previous noble gas, which is argon for selenium. Okay, so I'm going to go ahead and write the long form electron configuration really quickly. So selenium is 4p4 is where it ends. So I'm just going to quickly write it. Okay, I have these kind of, I've been doing this for a couple of years. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p4. Okay, so this is the electron configuration long form for selenium. So in order, you don't have to write all of this. You can do the noble gas abbreviation. So again, it's argon. So argon in brackets. So argon in brackets replaces all of this. So all of this actually is replaced by this. And then you would just do 4s2, 3d10, 4p4. Okay, so that's it. That's all noble gas abbreviations are. Okay, that's it. Okay, moving on. Electron configuration for ions. So you know that many elements will lose or gain electrons to obtain the number of electrons as a noble gas. So remember, guys, chlorine will chlorine will gain an electron to become like argon. Sodium will give up an electron to become like neon. Okay, so we kind of discussed this already. All of these, the reason they're gaining and losing electrons is so that they can all be like the noble gas. Okay, I've already said that in class. And then if two atoms have the same number of electrons, they are said to be isoelectronic. So that word isoelectronic, that just means same number of electrons. Keep in mind the proton number never changes, okay? So you can be isoelectronic with a noble gas, but you're not a noble gas, okay? You still have your number of protons. You just have the same number of electrons. Hi. What are you doing? What are you doing? Okay, sorry. Moving on. So we're going to write electron configurations, not just with neutral atoms, but with ions now, okay? So I'm just going to flip this paper. Electron configuration. I can't spell. That's a C. Oh my gosh. Electron configuration for ions. Okay. Wow. All right. So it looks like the first one we're doing is oxygen. Okay. So oxygen ion, which is O minus 2. You'll notice this has a +1 charge, +2 charge, +3 charge. And then these carbon family has a plus or minus 4. Group 15 has -3, -2, -1 charge, and then these are neutral. All right, so oxygen with a -2. How I like to do it, I like to first do the neutral electron configuration first. So electron configuration for oxygen, just the neutral oxygen, okay, is 1s2, 2s2, 2p4. Okay, so 1s2, 2s2, 2p4. Okay, that's the electron configuration for oxygen if it didn't have a charge. However, it has a charge. So keep in mind, guys, this right here, whatever this is doing, whatever this sign says, you want to do opposite, because remember you have an extra 2 electrons. So you're going to add 2 electrons here, okay? This really gets the kids because they think that you're supposed to subtract 2 and then you have 2p2, but you're actually going to do whatever this sign says to that last, the highest energy level, which is 2p, okay? Later, you'll see why I emphasize that. When you get to the d orbitals, you'll notice that the d actually will be lower. And anyways, so you have a -2, so you add 2. So the electron configuration for oxygen ion is 1s2, 2s2, 2p6. So that's the actual electron configuration for the oxygen ion. And if we wanted to go even further and write the noble gas configuration of it, of oxygen ion, okay? Here's your oxygen. The most recent noble gas, you can do this one, or since it's the ion, what is it isoelectronic with? Can you guys tell? What is oxygen ion isoelectronic with? Because you don't want to go up and to the right and then do it again, because if it's the ion, it's already isoelectronic with the noble gas. So these are a little different. You just do that, okay? Because it's oxygen with 2 extra electrons, and it's actually isoelectronic with the noble gas. So you will have that question on the test, and that's how you would answer it. Okay. And that last section right there, I already told you guys, it's not identical to the noble gas, and the reason why is because of the number of protons. Okay, so let's write electron configuration for rubidium with a +1 charge. So where is rubidium? There. Can you see? Oh, you can't see. So rubidium is here. We're not going to do the noble gas configuration because it is a noble gas configuration because it is rubidium with a +1 charge. So rubidium with a +1 charge. So again, I write its long form electron configuration, which is, we're gonna make it start all the way over here. We start from hydrogen, okay, and we just go like a book until we hit rubidium. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then remember 4s2, we have to jump back up to the 3rd energy level to 3d10. And then after 3d10, we're back up to 4p6. Where's rubidium? We are here. Okay, so 5s1 is the ending. Oh, okay, that could be 5s1. That's a 5. All right. So that's neutral rubidium. Neutral. Okay. Now, we want to take a look at the charge now, okay? Remember, you do opposite. So this is adding, so we're going to subtract 1 here. So keep in mind, once you have ions, we can actually lose an energy level, okay? So we're going to lose this. We're going to lose that energy level because 1 minus 1 is 0, and you're not going to put 5 as 0. You're just going to cross that out, okay? So the electron configuration for the rubidium ion with a +1 charge is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. Now, if the test asks you for the noble gas configuration of rubidium, okay, you just go up all the way, all the way to the right, and you have krypton. That is your noble gas configuration. It is isoelectronic with krypton, okay? If you do an electron configuration for an S or a P element and it is not isoelectronic with the noble gas, something went wrong, okay? Because when they bond with something, it's so they can be as stable as a noble gas. That's why they bond, okay? So there's our answer. We are right. I can't believe it. Example, given the electron configuration and charge, we need to find the ion, okay? So we have 1s2, 2s2, 2p6, okay? So we have basically 2p6. I like to just look at the last one. So we have neon, okay? We have neon, but we have a +2 charge, okay? So that +2 charge, remember guys, these are +1s and +2, okay? So if you are +2, you're actually losing electrons. So you have here, and then if you're losing the electron, you're going backwards to sodium 1 and magnesium 2, okay? Or that's how I do it on the periodic table. I just look at it, and then whatever it's isoelectronic with, which is neon, you just go back, you just add 2 electrons because it took away 2 to be neon, but add the 2 and it goes back down to the 3rd energy level. Or it was 1s2, 2s2, 2p6 with a +2 charge, okay? There are about 6 or 7 questions on the test with this. So what I do is I take this, okay, and I'm sorry. So you take this, and you remember how here we actually did the opposite, right? So we did the opposite, but we're working backwards now. So now you can, this tends to confuse the kids, but you can just add 2 here, okay? Because we are working backwards now. We are not given the charge we're not given the ion and doing the electron configuration. We are actually given the electron configuration, and we have to decide what the ion is. So we're backwards. So you actually keep the sign if you're trying to figure out the ion. So 2p6, there is no 2p8, right? So you actually have to add an energy level. So it's 1s2, 2s2, this doesn't change. 2p6, that's still there. But we have to add 2 electrons, right? So to add to 2p6, so what's after 2p6? 1, 2p6, 3, s1, s2, so 3s2. Okay, so you can either get the charges down, and what you do, if you're given an ion, you do the opposite sign. If you're given to do electron configuration, or if you're given electron configuration, you have to do the ion, do the same sign. So whatever is easier for you. For me, I like to look at what it's isoelectronic with. So it gave us up to 2p6, so that's neon, okay? With a +2 charge. Just go to the right and down. 1, 2. It's still both magnesium, okay? We'll go over a few questions in the warm-up. I highly suggest you pay attention to the warm-up. So that's how you find out what it is. So, and if it's negative, you're going to the left. So if it's positive, you go to the right, negative, you go to the left. So just to kind of show you 3p6, so this is 1, 2, 3p6, so we're at argon with a -3 charge. So it's minus now, so we're going to the left 3. So 1, 2, 3, so it should be phosphorus with a -3 charge, and it is, okay? Or we could look at the electron configuration it gave us. 1s2, 2s2, 2p6, 3s2, 3p6 with a -3 charge, okay? So what we do is we're going to subtract 3 to this, and that's going to be okay because there is a 3p3, right? So you do the same thing, 1s2, 2s2, 2p6, 3s2, 3p3, okay? So 3p3, so that's 1, 2, 3p1, 2, 3, that's phosphorus, and phosphorus has a +3 charge. +3, -3 charge, okay? Valence electrons. So you guys haven't been officially taught what a valence electron is, but I mean, I've kind of mentioned it, not officially to every single class. I am out of paper. So a valence electron, let's just go over what that is. It's responsible for bonding, and let's just draw an Bohr-Rutherford model, okay? we have nitrogen. Let's draw nitrogen, okay? Nitrogen has a nucleus, okay, nucleus. And then it's in the second period, so it has 2 energy levels. It has 7 electrons if it's neutral, okay? So if it's neutral, it has 1, 2, 3, 4, 5, 6, 7, okay? So 7 electrons if it's neutral. Valence electrons, valence electrons are just these. The electrons on the outer shell. That's all a valence electron is. These guys are involved in bonding. Nitrogen, you'll see, always has a -3 charge, or usually in 10th grade it always does. That's because it has space to accept 3 electrons, okay? It can accept 1 here, it can accept 1 here, and it can accept 1 here, okay? Valence electrons just means outer electrons, okay? That's it. So that's it. So how to find the valence electrons, which is what it said here, add the electrons together, pick the highest energy level. Let me show you what that means. So how many valence electrons are in potassium? So potassium, I'm just going to show you the answer because you'll see it has that 4s1. So 4s1, that's the highest energy level, is number 4. There's nothing higher than 4 on the energy level number, okay? And then it has 1 electron in that 4th energy level. So that's it. You have 1 valence electron, okay? Cobalt, let's do one. I wanted to do one in the d orbital. Okay, so cobalt. Okay, its electron configuration, I'm doing long form. Long form electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and we're at 4s2. So then 3d1, 2, 3, 4, 5, 6, 7. We've done this in another lesson. 3d7, okay? So we have our electron configuration. So all we have to do is find the highest energy level. And remember, everything underlined in red represents what energy level it's in. And remember, each energy level, it's just the ring around the nucleus, okay? So this is like the first ring around the nucleus, second ring around the nucleus, third ring around the nucleus, fourth ring around the nucleus, and third. You saw already the example with potassium, which wasn't weird, okay? The highest one was at the end. In this case, the highest one is not at the end, okay? The highest energy level is 4, which happens to be second from the end. So here, and then you count how many electrons the 4th energy level has. So the 4th energy level has 2 electrons in it. So then there are 2 valence electrons, okay? That's it. So easy. Neon, I can already tell you it's a noble gas. It won't have any valence electrons. Okay, yes it will, but that's involved in bonding. Sorry, my bad. I say one thing, I flip it, and it's the other. So neon has the highest energy level, if you'll see, is 2. And there are 2 of them. So, for example, neon, I've been doing this, I'm tired. Neon, 1s2, 2s2, 2p6. So neon, the highest energy level is 2. If there's more than one energy level, so for example, there's 3 here, but if it was happened to be the highest one, if there's more than one of the highest energy level, you add all of its electrons up. So that's 2 plus 6. So the valence electrons are 8. Okay, so you have 8. Sorry, they're not really involved in bonding though. Anyways, please post to the forum. Otherwise, if I notice the forum is empty, I assume no questions, I wouldn't come to me between classes and ask questions because it is a little too chaotic. I'm trying to get ready for the next class, clean up labs, whatever. So please post to the forum. If you see a question that is like super easy to answer, answer someone else's question.